Buonasera, benvenuti a tutti in Guiana Francese. Hello and welcome to the Guyana Space Center. Soyez les bienvenus à Kourou, port spatial de l'Europe. Nous allons ici, dans ce centre Jupiter, vous faire vivre tout bonnement ce troisième lancement de l'année, un lancement aux couleurs de l'Italie. Imaginez un lanceur conçu et réalisé par Avio pour le compte de l'Europe et sous la coiffe Prisma, un satellite de l'agence spatiale italienne. Vous allez découvrir tout cela tout au long de cette émission, mais on retrouve tout de suite la commentatrice anglophone, Katie Aswell, qui est au plus près des équipes. So Katie, it's over to you.
Thank you very much indeed, Thierry. Yes, and indeed a big welcome to everybody joining us tonight for our live broadcast here at the Guyana Space Center, the third launch this year. And as Thierry said, we are flying the Italian colours today because we are launching an Italian satellite called Prisma. Right now it's inside the launcher waiting for liftoff. That's scheduled in roughly 13 minutes' time. Now, the Executive Vice President of Missions, Purchasing and Operations at Arianespace is Luce Fabregat. It may be a long title, but she knows all about tonight's mission. And thanks indeed for joining us on the floor, Luce. So it is an all-Italian mission tonight.
Yes, you're right. It's a very Italian launch tonight. We launch Italian satellite built by Italian industry under the leadership of our customer of tonight, OHB Italia and Leonardo. And this satellite is for the Italian Space Agency. And the launcher also is very Italian because it was manufactured under the leadership of the Avio, the prime contractor. And so today I would like to say benvenuti a tutti.
And Luce, so we are 12 minutes now until launch. What's been happening so far in the countdown?
We started the countdown about 9 hours ago at the beginning of the afternoon here in French Guiana. Since then we have removed the mobile gantry. We have done all the operations to prepare the launcher for the launch, for the liftoff. And so now it has become more and more autonomous, more and more ready for the launch.
So after liftoff, what's going to happen? What can we expect to see? Because it's going to take about just under an hour, isn't it, to deliver our satellite?
Yes, the mission will last a little less than 1 hour. The launcher will flow towards the north over the Atlantic Ocean. We will have first the ascent phase that will be performed by the 3 solid propellant stages. Then the upper stage will be separated with a satellite, of course, on it. And then the upper stage, we will have with the upper stage a first boost of the AVUM, a little less than 5 minutes. It will be up to, I would say, Canada. And then we will be at an altitude, a very, very huge speed, an altitude of 200 kilometers, which is not so high. And then we will have a long ballistic phase of around 40 minutes, going up to the North Pole, and then on the other side of the Earth, going down up to Indonesia. And then at that point, the upper stage with the satellite will be around 600 kilometers altitude. And at that point, the main engine, will be reignited for a little more than 1 minute before the separation of the satellite.
Wonderful. Well, I wish you all the very best. Luce Fabregat, ladies and gentlemen, thank you very much indeed.
Thanks.
So we're going to find out now. We'll be looking to see what's been happening in the launch campaign.
Welcome everybody, benvenuti a tutti. The launch campaign has started with the arrival of 747 cargo plane the 11th of January. Prisma was transferred with the ground support equipment to the Guyana Space Center Preparation Payload Facility S1. After its arrival in this building, OHB Italia team successfully completed all the mechanical, pneumatic and electrical checkouts. Then the final preparations were performed before the spacecraft transfer to the S5 fueling facility on the 8th of February. Propellant filling operation were smoothly carried out without any anomaly 13 and 14 of February. After a few days of finalization, Prisma was ready to start combined operation with launcher on the 18th of February.
The first stage of the launcher is mainly composed of the P80 solid rocket motor, an engine containing about 88 tons of solid propellant. The launcher stage, directly on the launch table, is transported vertically on a track to the launching area. The second stage of the launcher, with the VV14 engine of about 23 tons of solid propellant, and the third stage of the launcher, with the VV09 motor of about 10 tons of solid propellant, are manufactured in Italy, in the Avio facilities of Colleferro, and transported to Guyana by boat. The stages are then transported to the launch area and integrated on the previous stage to complete the launcher. The fourth stage of the Vega launcher, with the Avum engine, has a liquid propulsion with storable propellants. It was integrated on the launcher on February the 8th, completing the launcher's integration after 12 campaign days. Over the next 2 weeks, launcher acceptance tests were completed. These tests verified the functioning of the electronic equipment until the simulation of the flight mission, the synthesis test, which took place on February the 22nd. Fluidic acceptance tests were completed on February the 23rd with the combustion chamber and racks subsystem tests. The Prisma satellite was then transported inside the fairing on February the 28th and integrated on the launcher the day after.
At D-3, we have performed the general dress rehearsal for the range, the launcher and the spacecraft, with all tracking stations involved in the final chronology on the flight. The Vega launch readiness review held on D-1 authorized the beginning of the final chronology to launch the VV14 mission.
Well, I've come up to my commentary box now, which is in the Mission Control Center, and that's what we're looking at, the Mission Control Center there from the outside. And back here we can see the Flight Directorate, arianespace top management. Luce Fabriguet, who we just chatted with, is heading up this team today. Top management from arianespace and Avio. And Ettore Scardecchia ran the Kourou Marathon on Sunday and he came second, so huge congratulations to him. We're travelling on board the 14th Vega launcher since it entered service 7 years ago, and as we've heard, it's flight number 14, VV14. That means Vol Vega 14. We have 3 launch vehicles here at the Guiana Space Centre. Vega's the baby of the family. She stands 30 metres tall. She weighs in at 138 tonnes. Take a look at the top of the vehicle. Inside there is our satellite. We call this pointy top of the vehicle the fairing. That's what Prisma looks like. And as we said earlier, really this is an all-Italian launch because we're orbiting an Italian satellite built by an Italian, the Italian prime contractors OHB Italia and Leonardo Space and Airborne Systems on behalf of the Italian Space Agency, ASI, and it's all travelling on board a rocket conceived, designed and built by the Italian prime contractor Avio, who leads a consortium of European industries all working together. That's what I call teamwork. Now this is the Mission Control Center, and on the right is not the real Ariane 5. It is a model, a near life-size model, but not quite as big as the real thing. And inside that building we saw, this is the Mission Control Center and the operational teams focusing hard now at this point before the launch. Now, as Luce said, the final countdown started just over 9 hours ago. And during that time, there were various major moments. The onboard computer was activated at L, if we say L is launch, L minus 4 hours and 40 minutes. The mobile gantry withdrew 3 hours and 15 minutes before launch. And the entire system was ready at -50 minutes. Now we're coming up to the next important milestone.
À tous de DDO, attention pour la séquence finale lanceur. Top, I0 moins 4 minutes.
And the range operations manager has announced the beginning of the synchronized sequence. This is the automated sequence. The computers are now controlling all the final checks in the countdown. They manage an impressive list of operations. And all of those systems across the base send information about their health status to these panels, which we can see on the right side of your screen. And we call them the status panels. They are showing us the status of 3 main systems: the rocket and pad, the range, and the satellite. The range is the name we give to the spaceport. The base here is about 750 kilometers squared, and that also includes the tracking stations, which are downrange of the spaceport. Now, we have a couple of control centers. Obviously, we've been looking at mission control, which is in charge of the whole mission. This is the launch control center. These teams are in charge of everything to do with the launcher and the pad. And then we have a number of different teams working in here, but primarily one of them is responsible for the operations on the ground, coordinating with mission control for authorization to launch. And everything, if everything goes according to plan, they're the team who trigger the automated sequence, and then the other team is responsible for the flight readiness of the vehicle, overseeing all the operations from assembly of the launcher to the moment of launch. We have quality teams as well working alongside them, making sure that everybody is adhering to the strict set of procedures. And they're based in a blockhouse, protected blockhouse, which is about a couple of kilometers from this pad. So they're very close to the pad. They're watching over all this final phase of the synchronized sequence. We're 1 minute now and 37 seconds to launch. Here are all the VIP guests who you saw inside the Mission Control Center are now coming outside onto the terraces outside to go and watch the launch with their own eyes rather than watching it on the screens here.
À tous de DDO, attention pour moins 1 minute.
Coming up to the 1 minute mark.
Top, I0 moins 1 minute.
And we're 1 minute to launch. Time to say our very best wishes to everybody who's worked so hard for today, to the Prisma teams, the industrial consortia led by OHB Italia and Leonardo, the Italian Space Agency, the operational teams who are waiting to fly their satellite once it's separated, to CNES, ESA, arianespace, and of course to all of you who are watching us on the internet. Good luck everybody for the launch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80, décollage de VV14 Prisma. Propulsion nominale. Propulsion nominale. Acquisition de la télémesure par la station de Saint-Jean. Pilotage calme, propulsion nominale.
And they are off. Prisma has started its journey. Vega blazing a trail across the night sky here in the skies over the Guiana Space Center. The Vega launcher takes its name from the brightest star in the galaxy of Lyra, in the constellation of Lyra. Fifth brightest star in the night sky, and tonight she is lighting up our night sky. Heading north now over the Atlantic.
Séparation P80.
And we can see the separation there of the first stage.
Allumage Z23.
And he's telling us that the second stage is switching on, the Z23. This is what we're looking at now.
Propulsion Z23 nominal.
He's telling us that the propulsion of the engine is nominal. And there's the beginning of the dog leg maneuver. The dog leg maneuver is taking us out towards the north because we've been flying rather like an aeroplane. When it takes off, it has to go on a certain trajectory because it comes off the, I was about to say launch pad, but the runway, of course. And then depending on which direction it's going in, it turns and flies in that direction, and that's what the dog leg is. We have turned and we're flying towards the north, and he's telling us that everything is going normally. Top right-hand side of the screen is our trajectory. The cross is the actual position of the launcher. End of the dogleg maneuver, and all the parameters are normal, he says. And you could see just at the bottom of the screen there, we'll be seeing it again. There we go. Our altitude, 134 kilometers above our planet, on the bottom left of the screen. In the middle, our distance. That's the distance from the pad, if you were to draw a straight line, from the pad across the Earth to the position where the launcher is over.
Séparation Z23.
On the right, the speed, and now confirmation of the separation of the Z23 stage. Burnt its fuel, we don't need it anymore. There's a few seconds.
Z9.
And we have a confirmation of the
Séparation de la coiffe.
Z9 is now switched on, and the engine, the fairing, has now been
nominal.
jettisoned. The propulsion, he says, is nominal. So we don't need the fairing anymore. It was protecting our satellite from the rigors of the launch. It was protecting us from friction. It was protecting us from the acoustic vibrations at liftoff. I'm sure you can imagine just how loud that is, or was. And so we are officially in space. This is what it looked like. We lifted off from the pad 4 minutes and 40 seconds ago. From the pad, you can see it there in the Guiana Space Center on the northeastern coast of South America. Galileo is the tracking station at the Guiana Space Center. Vega shot into the sky.
Fin de mission sauvegarde.
Shot into the sky, and it was a beautiful launch. We managed to see it all the way until the separation of the first stage, so that we were very, very lucky. We've crossed the threshold. Crossed the threshold into space a little while ago. That was 100 kilometers above our Earth. We call it the Kármán line, the border with space. At that point, the atmosphere is so thin that it can no longer support vehicles with wings. So if we want to stay up once we're above the Kármán line, we have to use rocket science to do that. We're looking on the right-hand side of the screen at computer-generated images.
Pilotage calme.
The experts put a series of data and predictions into the computer, and this is a simulation of those predictions, so a simulation of exactly what's been planned for the flight. It's great because it means we can visualize it, we can see what it looks like up there.
Séparation Z9.
And we have separation of the Z9, Z for Zefiro, a kind of wind, an Italian wind, a little bit like the Sirocco or the Mistral. So, third stage has switched off its engine. The main propulsion phase of the flight is now over. And we are picking up the signal at the tracking station in Bermuda, an island in the Caribbean. And correct me if I'm wrong, I think the tracking station is actually on Cooper's Island, which is just to the east of Bermuda. In fact, the teams at the Bermuda tracking station have been a long-time space partner, dating back actually to the NASA days of the first manned space program. That was called Mercury, late 1950s and early 60s. And then, of course, as well with the Apollo lunar program in the 1960s. Our flight path takes us north, as Luz described earlier, heading up over the Caribbean, along the east coast of the US, east coast of Canada.
Fin d'acquisition d'un télémesure par la station de Galileo.
And the Galileo tracking station has now, we've now gone out of range of the Galileo tracking station. That's the one that was at the Guiana Space Center.
Allumage AVUM.
And we've switched on the engine of the AVUM first stage, or AVUM as it's pronounced in French and maybe in Italian as well. So we've really started the next phase of our journey now.
Nominal.
Everything's going according to plan, he says. So AVUM has taken the wheel, and its job is to deliver our satellite to its required drop-off in space. It has to climb us up to 625 kilometers above the Earth to do that. You can see on the top right-hand side of our screen how we started off climbing quite steeply, and we're plateauing out now. Our altitude at the moment 253 kilometers, so we've still got another few hundred kilometers to go.
Propulsion nominale.
Today is Vega's 14th mission for Earth observation. Sorry, it's 14th mission in total, and 11 of those have been for Earth observation satellites. You can see our flight path there, heading, although we've gone into the range of the Bermuda tracking station, we haven't actually got to Bermuda yet. Yep, so Earth observation involves using satellites in space to gather information about the physical, chemical and biological systems of our planet. And Prisma is going to do a very important job. So let's find out more now about our satellite.
Propulsion nominale, les paramètres à bord sont conformes à la Acquisition de la télévision par la station de Saint-Hubert au Canada.
And during that film, we
Il
picked
reste
up.
moins d'une minute de propulsion de la VOM.
He's telling us we've got 1 minute left of propulsion on the upper stage. And we picked up the signal at the tracking station in Canada during that film. It's in Saint-Hubert or Saint-Hubert in Quebec, just outside Montreal. And the aerospace industry is important there too. The Canadian Space Agency has its head office in the borough. Now we're tracking using telemetry. These tracking stations have big dishes which pick up the signal from the launcher as it flies over, and that information gets sent here to the CVI, the teams here
Trajectoire nominale.
at the Guyana Space Center, telling us how the flight's progressing in real time. Those are the 3 tracking stations.
Première extinction du moteur à VOM.
And we have the switch off of the upper stage engine now. So we're entering the first ballistic stage. Ballistic's a word that we often hear, but what does it actually mean? Well, I believe that it means that we are travelling without propulsion. And that's what we're doing right now, because we are high enough and fast enough to cruise without the engine. And this ballistic phase is going to last for 38 minutes, roughly. We're also doing various manoeuvres here. The upper stage is a very clever piece of kit. It's called the AVUM because that stands for Attitude and Vernier Upper Module. It's the smart part of the launcher. It's the command and guidance module. It's a little bit like the cockpit in an aeroplane. Its job is to deliver our satellite to a very specific orbit. And it's designed to inject different payloads into different orbits because each satellite requires a different separation orbit, a different place to be deposited, if you like, or delivered to in space.
L'étage à VOM est en phase balistique.
He's just confirmed that the AVUM upper stage is in the ballistic phase. And so that's why it can switch its engine on and off so that it can take its passengers anywhere they need to go. It's a little bit like a sophisticated taxi driver. You can see it twisting, can you? Looking a little bit like it's on a spit. Well, I believe it is right now in what we call the barbecue phase. Let's hear more about our satellite from our Italian friends.
Tonight, Vega launcher will deliver Prisma spacecraft to a sun-synchronous orbit at an altitude of 615 kilometers. Prisma, precursore iperspettrale della missione applicativa, is an Earth observation satellite mission funded by Italian Space Agency.
Prisma is a full Italian Earth observation mission based on a single satellite, carrying an epispectral imager that will characterize the Earth's surface on a global scale, extracting geochemical, biochemical, and biophysical parameters, providing unique information on the status and evolution of our planet. Hyperspectral imaging is an innovative remote sensing technology that acquires image data in hundreds of narrow continuous bands, from the visible to the shortwave infrared. Each individual pixel of the hyperspectral image contains a continuous spectrum of the solar radiation reflected by the surface. These spectra include absorption features, which can be interpreted as spectral fingerprints of Earth elements that allows to identify minerals in rocks and soils, to analyze vegetation types and conditions, and to detect pollutants in water and air. Prisma missions have been developed under the aegis of my agency, the Italian Space Agency, through a joint venture of Italian companies led by OHB Italia, responsible for the platform and the system, and Leonardo, which built the electro-optical instrument.
The satellite platform has been designed and developed specifically for Prisma by OHB Italia. The principal electronic units have been realized in Italy by us and our partners, including the onboard computer, the power control and distribution unit, the tube batteries, and the payload data management unit. In doing this, the Prisma industrial comport has maximized the reuse of the heritage from the previous missions funded by ASI and by ESA. The assembly, integration and test of the satellite has occurred in OHB Italia clean rooms, located in the north of Italy, starting from beginning of 2018 and involving several months of very intensive job for all our company, which makes us very proud of that.
We are very proud of Prisma at Leonardo, where we designed, developed, tested and calibrated the payload for Italian Space Agency. For 10 years, about 100 people worked for this project in Campi Bisenzio, near Florence. It was a big technological challenge that we face thanks to the commitment of the team and the strong support of Italian Space Agency. At Leonardo, innovation is one of our values, and the Prisma is a true example of how innovation becomes a valuable product. The payload capitalizes several new technologies, such as a challenging passive cooling system, optical coating, and advanced processing for image quality. The program is the result of an excellent cooperation among Leonardo and OHB Italia and many other Italian small and medium companies.
The scientific community and other users will be able to employ these capabilities for a number of applications, including environmental monitoring, resource management, identification and classification of crops, the fight against pollution. For Arianespace, the journey for preparing the Prisma mission began in June 2017. Since then, many milestones have been accomplished to reach this final and actual successful step. I would like to thank all the teams involved in this program for their professionality and spirit of
cooperation. La prochaine acquisition de la télémesure lanceur est prévue dans environ 30 minutes par la station de Norcia en Australie.
So telling us in about 30 minutes' time that we'll be picking up the signal at the tracking station in New Norcia, that's in Australia. And Prisma will be the third satellite which Arianespace will have launched on behalf of the Italian Space Agency, ASI. There are 2 more to launch, 2 more in the order book. They're actually a pair of satellites, and they are called Cosmos SkyMed Second Generation. They are scheduled to lift off on board a Soyuz and a Vega C. Thales Alenia Space built them for ASI and the Italian Ministry of Defence. So that's a nice launch to look forward to, or 2 nice launches to look forward to. So the Avum upper stage is due to switch its engine on again in about 32 minutes' time for its second burn. We're going to take a break now for about 25 minutes. And during that time, we'll have a planned gap in visibility because we'll go outside the range of the ground stations for a little while. So during that time, we won't be getting any information from the launcher. That's all perfectly normal. It'll download the information to New Norcia when it gets there. And so I'm going to be coming back to you at 11:34 p.m. here in Kourou. That's in Italy, 3:34 in the morning. And universal time, that's 2:34 in the morning. In the meantime, we're going to leave you with a beautiful replay of our launch 20 minutes ago.